Good day, everybody. I have a problem that's slightly more challenging, I would say, than the corresponding SMO problem, Singapore Math Olympiad Junior 2015. And I think for that problem, you actually had to calculate the prime factorization. I'm going in reverse here. I'm giving you a prime factorization. I'm telling you it's an LCM, and I want to know how many consecutive natural numbers would correspond to this least common multiple, folks. That's what LCM stands for. It's an abbreviation for the least common multiple. It's the smallest number that is a multiple of the given numbers. Okay. So now a natural attempt here, noting that 19 is the largest prime factor, is just to consider, 1, 2, 3, 4, and we'll do our good friend the labor-saving ellipsis here, dot, 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 18, 19, okay? And of course, we're leaving out 5, 6, 7, all the way up to 17. Now notice that 16 would be in here somewhere, right? Well, 16 is 2 to the 4th, okay? And notice that will cover up, so to speak, any other powers of 8. 2 cubed would be here also, but 2 to the 4th is the highest power of 2 in amongst these 19 numbers, okay? So notice that 2 to the 4th is in the prime factorization of our purported LCM. Okay, now also we have a 3 here, and also 3 squared would be in here somewhere also, right? But 3 cubed is not here, right? Just like 2 to the 5th is not here. Okay, so 3 squared would take care of all the possible 3's throughout the problem, okay, throughout that list of numbers, okay? And you can visualize 15. 5 would be the next one, so we have a 5. There would be another multiple of 5, 10. There would be another multiple of 5, 15, but no powers of 5. So that's why it's just 5. And similar arguments for 7, 11, 13, 17, and 19. So again, I'm claiming that this is the first such case. So we know that K would be the smallest. K equals 19 would be the smallest of the K's satisfying this condition, right? Now again, just let me move down here and give you a simpler example here for smaller, more believable numbers. 3, 4, 5, the least common multiple of 3, 4, 5 is 60. And if you add 6, which just is 2 times 3, you still have a least common multiple, which makes complete sense, right? Or it's 2 times 3 has already appeared as a factor of 4, and then we have a 3 right here, right? So adding 6 to this will not alter the least common multiple of these 3 numbers and these 4 numbers. It's the same, okay? And they're consecutive, right? Okay. Now they're not the first consecutive, but anyway, hopefully that helps. You can have different collections corresponding to the same least common multiple. There's no doubt about that. Now notice in a very similar fashion, if we add K equals 20 here to our list, notice that this is just 2 squared times 5, right? So all of those values, all of those numbers are already in the prime factorization. All those prime factors are already in the prime factorization. Okay, we can go on. K equals 21. Again, we don't get any new prime factors as a way to think of this. K equals 21, which is 3 times 7, right? Okay, well, look, 3 and 7 are already there, right? Okay, let's keep tracking here. That's now K equals 22. And remember, we're just finding how many K. We don't have to really, we get the numbers in the process, but this is 2 times 11. These are semi-primes, right? So that's 22, right? So far we've produced 4 Ks. 1, 2, 3, 4. Now let's say that we consider K equal to 23. Well, hopefully that's clearly impossible here, because 23 would not be included in this prime factorization, right? So this is K cannot equal to 23, because it would violate the fact that 19 is the largest prime divisor of our purported least common multiple. But we have shown that there are 4 values of k. 4 values of k, the 4 that I've listed right here. So the answer would be 4. Four values of k. I'll just do it like this, 4 k's to be clear here. 4 k's, apostrophe, is the answer. And so we see that, among other things, the LCM function, if you think of it as a function, I think you can do that in a fair sort of way. It's not a one-to-one function, right? Because right here we've produced 4 different numbers, 4 different collections of numbers of varying sizes that have the same LCM. I'm not quite sure how LCM, it can be thought of as a function of, I'll have to be a little more careful about saying that, but I think you can think of it. So if you can think of the LCM as a function, a number theoretic function, it's not a one-to-one function, and this is a nice example of that. This was an example as well, okay? So anyway, again, here's 1, 20, 21, and 22, along with 19. Take care of business here to get 4Ks. All right. Thanks for viewing.